Hi, I'm going to talk about the average, standard distribution, mode, and median today in statistics, and explain how they're derived or what they mean. And we'll do one example here with some numbers I just randomly picked. So starting out, this is my key again. Um, Whenever we see an X with a line over it, that is representing the average, or the also known as the mean in statistics. Whenever you see just a purple N, that's the number of trials or the number of data points in a whole set. Like here, there would be 1, 2, 3, 4, 5, 6, 7, 8, 9. There'd be 9 of them, and that, so N would be 9 for this. Whenever you see a sigma, which it's a lowercase sigma, the uppercase sigma would be like an E, like uppercase E that looks like that. That's used for Raymond sums and stuff. But whenever you see the lowercase sigma, that is the standard distribution, which I'll talk about in a little bit, which is a measure of how points are varying, how data points vary, how much they are different, how much disparity there is in your set of data. X, whenever you see an X with a number next to it, that is denoting any one of these points. So instead of N being, N is the total number of them, whenever you see an X with an I or an X with a number next to it, you're representing any one of these given values that you're looking at any moment in time when you're adding together, for example, or subtracting. That's what X with the lowercase, with the subscript next to it means. So starting out, this is the average, also known as the mean. To find that, you just add up all of the data points, you just add them up, and then you divide by the number of data points that you added up. And so what this ends up doing is basically evenly distributing, if you want to say like the wealth, between values. So it's kind of like creating a socialist value from the ones that are really rich or really poor or in the middle, taking all those, adding them up, and then dividing it evenly among them to get some kind of maybe average value, like some kind of representative value. So if we add up 1 plus 6 plus 4 plus 7 plus 2 plus 5 plus 3 plus 5 plus 8, we add them up, we get 41, and then we divide by 9, I think it was, 9, which is N up here. We get 4.5555. So the average of these ends up being 4.5555. So that is our average value for these. Now let's say we want to know, we could make an average, but what if one of them is like 1,000 in the set and it's way different than the other ones? Well, in statistics, they probably throw it out, and there are ways to do that to determine whether it's not really belonging in the data set. There was clearly some error and it skews it enough. So if you don't do that though, and some values are just a lot higher and the other ones are lower, but maybe most of them are lower, how do you know just from like one value how much you can expect a set to vary? Well, that's what the standard distribution, the standard deviation does here. It is a measure of how much they're distance apart. So to do that, first we find the average, which we did, and that's what this X with the line over it is in here. And then we got to take each data point and we have to subtract the average from it. So if it is, you don't actually have to do it in that order actually in here, since we're going to square it and then take the square root of it again. But if you're calculating variance, which is without the square root, then I guess it may matter. Maybe, no, it doesn't matter, never mind. Okay, so, because we're still squaring it and that undoes the sign. So first we want to take 1 minus 4, I'm just going to use 4.5, or let's use 4.6. 1 minus 4.6, and then we gotta, actually it's going to take a little bit longer than I thought it would. Square that, and then we add the next value, which is 6. So we gotta go 6 minus the 4.6, and then square that. Then we add 4 minus, oops, in parentheses, 4 minus 4.6, and then square that, plus, in parentheses, 7 minus the 4.6 squared, and then add the 2, then we gotta do the 2, so 2 minus 4.6, square that, and then add 5 minus 4.6, square that, and then 3, hit that with 3 minus 4.6 squared plus 5 minus 4.6 squared, and then add the 8 with the 8, so 8 minus 4.6 squared. When we add those together, we get like 42.24 in the numerator here. Then we have to divide that by n, which was 9, right? So we gotta divide that answer by 9. Then we end up getting 4.69333333, and that is the variance, which I'm not gonna talk much about, but that's the standard distribution squared. But what we wanna do is, so basically what we're doing is finding the difference between them and each value point and the average. How far away are they from the middle? And then we're squaring them, which is getting rid of the plus or the minus value of it, and dividing by n, because that was the number of times we did that. So it's kind of like an average of the distance between them. But then we're taking the square root of that whole thing, including n, which I'm not really exactly sure why we do that, but maybe that works out. It's like taking the square root of, I'm not sure why we take the square root of, I can't tell you for sure, but that's just convention in what we do. So now we're going to go the square root of the answer, which was 4.693333, and then we get 2.166410241. So what we end up with here is just under 3. Let's go this side. 2.17. Basically what we get. So with this set looking like this, the standard distribution is 2.17. Now we'll talk a little bit more about this in a subsequent video, but the standard distribution is really important in statistics. It can help you if these numbers are following a trend, like a normal distribution is what it's called, that's seen in nature a lot. If it's following one of those where they're kind of distributed based upon, there could be different factors that influence what the number becomes for each trial that you do. If there's multiple factors for that, it's probably going to end up being a normal distribution, and I'll talk a little bit more about that later. But basically, if you know what the standard distribution is, and you can basically start to figure out the probability of finding a value that's a certain level or above, just from this value right here, which is really useful. So that's the standard distribution. Moving on to the median. the median is the middle value in the set. If it's an odd number like this, I think it is, I think it said 9, then the middle value, when we rank them in order, which we'll do in a moment here, is the number that's in the middle. If this was an even number of points though, then we would actually want to take the 2 middle points, because there's no actual middle point otherwise. And we take those two and then we do the average of those to find what the median value is. Because sometimes you could have an average that's not the same as the median too. And kind of having an idea of how much it's favored one direction or another, how it's distributed, it can also help to know that, to just as a, I don't really know math that uses the median right now, but if you know what the middle value is, but what the average is, if the average is higher than that, you might think, well, there's some values there with a lot more than the others. You know, like with income, for example, a lot of times they use the median income, which is the middle value of income. Yet the average might be higher than that because some people may have like a lot more money, right? So moving on to the mode. Actually, let's calculate the median real quick, or let's find the median. So that is going to be, we got to rank these data points. So if we do that, we end up with 1 and 2 and then 3 and then 4. Just going to cross them off. We end up with 5, 5, gets rid of the 5s, 7 and 8. So the middle value here is going to be number 5, which just happens to be 5, I guess. That's also going to be our mode, and I'll tell you why in a moment. Oh, I did that incorrectly. Hold on, I missed a number. Oh, I forgot about the 6. Never mind. But I think it's still going to be a 5. Let's see. Five, 6, 7, 8. So it still ends up being 5 in the middle. That is our median. Now, for the mode is the data point value that you see the most in the whole set. So it's possible to not have a mode. If every single number here in that list was unique, then there wouldn't be a mode. But in this case, one of them I purposely put in there as more than once, and that would be the 5. It's also possible, let's say we had another 8 or something in here. It's possible to have 2 modes, but let's say we have one more 8 in here. At that point though, we can say, well, there is only one mode, because that's the one with the most, because 3 is more than the 2 5s. So you go with the point that is most represented. So in this case, there was just one mode, but there could have been 2 modes, and there could have been multiple points that were repeated, but they weren't as repeated as whatever the mode is. So that's going over those 4 things: the mean, the standard deviation, the mode, and the median. And it will be like this. Thank you.